Thank you, everyone. Hi, good evening, good afternoon, good morning. Today we'll be talking about CI/CD and being at the heart of accelerated Kubernetes adoption and at the heart of deploying applications on Kubernetes. So what we have in on the agenda today, we'll look at what makes a good Kubernetes cluster, the challenges around that, how to maintain this Kubernetes cluster or clusters, and then definitely how to increase the adoption, right? How to deploy applications more rapidly, more securely, and in a continuous manner. How we'll do that? We'll do continuous integration and continuous delivery. So these are very generic terms in this agenda, but we'll look at these in a very, very specific to Kubernetes, to the Kubernetes ecosystem. Okay. So I am Daniel Virassamy. I'm a principal cloud solutions architect working for Mirantis. I've been in this space for quite some time now, been working with open source solutions, mainly, whether it is operating system, whether it is cloud and infrastructure, and now containerization platform. I am a cloud enthusiast and definitely an open source advocate. I will be accompanied by Roman today, and Roman will be happily answering your questions. So before that, let's look at what we'll be using for the demos, because this session is not only about presenting and doing slideware, but it's also about showing you how actually all these work together. So let me just jump on Lens. So this is a tool called Lens. I expect that many of you already know this tool, but for those who do not know Lens, this is, if not the most popular, one of the most popular IDE for Kubernetes on the market. It is part of the CNCF landscape. And one of the major advantages of Lens is that it allows you to manage multiple clusters through a single pane of glass, right? So here you can see that I'm managing multiple clusters, 4 clusters actually in this panel. But if I go back to the catalog panel, you will see that I have many clusters that I can run and manage within that single panel, right? To connect to these clusters, it's very, very simple. I just need to click on one of these. So this is an EKS cluster that is deployed on AWS, and basically it's added to Lens, and I just need to click on this cluster, and as from there I can manipulate all these different objects, whether it is workload related, pods, jobs, daemon sets, stateful sets, networking config, secrets, storage, namespaces, Helm. So all these Kubernetes objects, right? Even your own through custom resource definitions. Lens is not only focused around managing Kubernetes clusters at scale. So not only one cluster, but multiple clusters. Not only one cluster coming from one provider, but in a multi-cloud environment. So you can have EKS, Mirantis Kubernetes Engine, AWS, Azure AKS or Google GK, right? And you can have all these clusters being deployed within Lens, and then you manage all these for that single pane of glass. But you can also define your own extensions to Lens. For example, here you can see that Mirantis developed an extension for Mirantis Container Cloud. So Mirantis Container Cloud is a multi-cluster deployment component. It is Mirantis multi-cluster deployment component. And by doing that extension for Lens, we are able to expose the different clusters that we are creating for Mirantis Container Cloud, right? Or through Mirantis Container Cloud, we are able to directly expose these into Lens, right? So we don't need then to download the kubeconfig file and share this kubeconfig file and add these to Lens, for example, or any other tools. So this is a breach of security. So in this case, the kubeconfig is never shared. It's a direct connection between Lens and Mirantis Container Cloud through that extension, and we are able to connect to all these clusters that are being built within Container Cloud, right? Again, you can build your own extensions. This is a framework which is based on the Chrome framework. So basically, You just need to build your extension based on Node.js and Electron, right? Here you can see some other extensions that some other parties have built, like Aqua built Starboard extension. Flux built a Flux V2 extension. We, as Mirantis, built an IoT management extension. So you can build and add your own extensions in Lens. One other major advantage of Lens is that you have that notion of space, right? So here you can see that it is local. So this is my local environment. But if I do click on, let's say, for example, Lens Autopilot, this is a space where I can, through that single space, manage the access to clusters to very specific team members. So how that works is I create a lens space. Then within that lens space, I add people, right, to that given lens space. So here you can see that we have a couple of people that are already within that lens space with different membership privileges, whether they are admin, owner, or members. And then I just need to add people to that lens space, and all the people that have access to that lens spaces will have access to all the clusters that we are sharing within that lens space, right? And to share a cluster to lens space is very, very simple. You just need to click on your cluster, go to settings, go to cluster connect, yeah. And as from there, I just need to select the lens space that I need to add it. So here it's already in DB Autopilot, for example. So I would need to remove it first and then add it. But basically, if it's not added, you select the lens space here. You select the region where you will be handling this space, and then you just click on Add Cluster to Spaces, right? And as from there, that cluster will be added to your space, and all the different people within that space will be able to connect and work on that single cluster. So that's a major also advantage of Lens Pro. We also have the security center. This is something which is quite interesting, and this is also important when we'll be talking about CI and CD. To have that capability to have within that cluster and Lens have that ability to scan images and other resources of your cluster and have a quick view of how vulnerable your applications are, right? So you will be able to see the amount of pods that have been scanned, the results in terms of vulnerability and not vulnerability. So here you can see that we are not very good. And then how many of these are critical, high, and medium, right? And exposed secrets is also something which is very, very key, whether we are having our secrets exposed or not. Okay. And the last element of Lens, which is also interesting, and this is also part of the CI/CD concept, is to have LDK. So LDK is the local development Kubernetes cluster. So basically here you can see that it is running, and to access it, I just then need to click on Open Cluster, and then within Lens, I will have access to that given Lens desktop cube. And as from there, I can access that cluster and build my images and test my images locally before pushing my images or committing the code and then having all the CI/CD pipeline deployed, right? So this is a Lens in a nutshell, where we saw multi-cluster management, Lens spaces, Lens security center extensions, and then Lens desktop cube. And that will be one of the key components that we'll be using during this session to highlight how we are using CI and CD to accelerate the adoption of Kubernetes. Okay. So what is a good Kubernetes platform? With Mirantis, we typically would align our architecture based on customer use cases, definitely, on these 5 big pillars. One is how fast the customer will go to production, right? So how fast we will move from being from the design stage to the production stage, right? And what does that mean is how generic we can make that platform, right? And leverage all existing capabilities in the ecosystem. so that one, we don't reinvent the wheel, and two, we are able to leverage again all the work from open source communities and all that, right? We need then to have that capability of deploying fast to support and manage properly at different scales and in different environments. The second thing is security. There is no compromise or trade-offs around security. So this is very, very key. So how we build in security certifications and best practices as part of the design. Central point of collaboration, as I already shared during the Lens presentation. You don't want to download your kubeconfig and then share that across the board, right? You want to keep that kubeconfig file within a central point and manage that centrally and collaborate centrally through one single pane of glass. That eases the whole process. It also helps collaboration and troubleshooting. We, for example, at Mirantis, we highly leverage Lens for that. Roman, for example, we work together a lot on common Kubernetes clusters. And one of the way of doing that is through Lens and Lens spaces. Again, and basically what that means is it just eases everything, right? I don't need to go and download kubeconfig files, share it with him, manage tokens around these and all that. It's all managed centrally and easily through these spaces. You also want to apply or achieve operational excellence through this pillar by having proper logging, monitoring, and alerting system that is able to cover all your clusters, get the proper reports and alerts from these systems, so that you get the proper observability on these clusters and make sure that you're making the right decisions when defining, deploying, configuring, and using these clusters, right? Flexibility, definitely. Right now, we are in the age of multi-cloud. We are definitely not, and many of our customers are not using one single solution. They are on various public clouds. They have on-prem clusters, and they want to have that flexibility. They want to have the flexibility of moving around workloads across these different environments, easily use all these environments, extend these as they want, and not be locked or blocked within a single solution because they can't change CNI, they can't change the storage backend, they can't add their own security tooling and all that. And then future-proof basically by having no vendor lock-in, so not attached to a single vendor which defines a solution through one single way. So this is where open source is very, very key, and having the choice of operating system, choice of Kubernetes clusters, and choice of the components that you are using, and having that freedom to move and scale as required, right? And if you look at all these different components, all these different pillars, whether it is fast time to production, security, central point of collaboration, flexibility, and future-proof, well, again, automation is key, right? Automation is key to go on to production very, very rapidly, whether it is to deploy these clusters, manage these clusters, but also to deploy applications. So you need automation. Security, you can't at scale do security without automated process, whether it is for around tooling, but also getting the proper observability around tooling, central point of collaboration. We discussed about logging, monitoring, and alerting. You do need to have automation around that. Flexibility, if you need to move workloads around, if you need to implement at scale your components in different environments, you also need automation. And then future-proof, definitely automation is something that is going to guarantee you having better future-proofing for your solutions, right? And behind automation, what you have is continuous integration and continuous delivery. But what are the challenges then that we are looking at? Some of the challenges that we are looking at is the different options that you have to actually build your solution, right? Whether it is for CI, whether it is for CD, you do have, and that's only some of the cards that you would get from the CNCF landscape, but you have many others, right, that are not part of this CNCF landscape. And you do need then at that point to select the proper tooling and then invest on these tooling. And what I mean by investing on these tooling is you then need to integrate these, configure these, train your team, and then develop on these tooling, right? And once this is done, you are in for quite some time because you don't want to change your pipeline every year, for example, right? This is a massive investment in terms of selecting the proper solution based on your requirements. And this is very important because each and every one of these tools is adapted to your specific use cases. So selecting the proper one then, and then integrating these properly, securing these, maintaining these, right? Assuring that you have the proper lifecycle management system around these components, updates and upgrades, security patches, and then you start to use them, right? So it's one of the challenges that many organizations we work with have, simply because it is time consuming, and it kind of also many of these companies then do not spend time on developing or creating innovation within the application, but spending more time creating the tooling and maintaining the tooling to be able to do innovation, right? So that's a key challenge. The second key challenge is finding skills, hiring them, and then retaining these skills, right? And I do like some of these statistics. And this is something that is coming from Kubernetes in the Enterprise Survey from March 2021. But looking at 2022 and 2023, the trend is exactly the same in terms of finding enough skills, hiring them, and retaining them, right? And if you look at, for example, 38% of developers claim that they are extremely tired because of not only having to develop and bring innovation in the code, but also having to maintain the tools, securing these tools, and doing a lot of operations in terms of DevOps, right? So they are DevOps, but it's more ops than devs, that development. 51% of developers say that building cloud native applications make them want to find a new job. And this is a little bit more worrying, right? So this means that definitely there is something that needs to change because of the amount of work that is now required to maintain the ecosystem. And that ecosystem is getting more and more complex. And again, each and every tool means investment in adoption, investment in training, investment in development and using these and maintaining these tools. Good thing though is that organizations are planning to hire in this space and train in this space, right? So then again, it's all about retaining the right skills and bring innovation. But if you mix the two challenges, so complex environment, a lot of CNCF, CI/CD cards, more tools around, proper selection of these, maintaining these, and then the challenge of having people to do that, then this is where typically the adoption of Kubernetes is slowing, right? Can be slowed a little bit, right? And that's not what you want. That's not the promise of Kubernetes. The promise of Kubernetes is basically to increase the capability to deploy applications more rapidly in a more cloud native manner and bring innovation faster to the market. So let's look at the continuous integration piece. Typically on the application side, you would have 4 big steps. The first one is build, right? So you need to build your code. That's where you would start. Definitely you can start earlier in this process, where before building your container images, you would already do some CI in terms of scanning your code with Nexus or Prisma and Agent, and then see whether you already have security breaches at this step, right? So that could come before the build or as part of the build process. And then definitely then you have your Docker file. And once you have that Docker file, you would build your container images, right? So that's step 1. Then step 2, what you want to do is to enforce Docker content trust. And what that means is you want to sign your images. Use a private key, sign your image, and make sure that your image is signed. And then you can use that signature afterwards when you will be running your cluster, right? Running your application. Then the third step is share, right? I've built my image, I've signed my image, now I want to share it. And what I mean by sharing it is to push these images in a trusted central source of truth. That's basically your image repository, right? And from that image repository, then you can have various capabilities, and some of these capabilities are scanning. So that's why at step 4 you can see scan, and scanning to check all the vulnerabilities that would be present in your image. In that case, not only from your code, but also from all the dependencies that you have within your image that you have brought as you build your image. So you would be looking at all the layers of your containers and then see whether you have minor, major, or critical vulnerabilities within your container image, right? And based on the result of this, you can promote. And what I mean by promote is, let's say you have various repositories, you have dev repositories and you have production repositories. You can automate the process of moving images from dev to promote, from dev to prod based on the scan results, right? So everything can be automated. And basically all these steps, 1, 2, 3, and 4, can be automated and can be automated through pipelines, right? So if I look at here, this is an example of how we would do it and how we would do it using Mirantis container runtime, MCR, which is the runtime, Docker runtime. MSR, Mirantis Secure Registry, which is our secure registry, right? Container registry. And then for running, we have Mirantis Kubernetes Engine, right? But the important step here is we want to build and share. So how that will work is, if you look at this pipeline, for example, okay, let me connect to this one. If you look at this pipeline and we look at the console output, you will see that here we are doing things that are very, very standard. So first thing is we get the image, right? We clone the repository, so git checkout, and then as from there we build, right? So we call it Docker build, and we are building a simple Nginx image here. Once this image is built, then we do some basic tests. So basically here we are doing some what we call unit tests. Very simply, we just do a Docker inspect, right? In your use case, definitely you will have more advanced testing. So basically your pipeline will be a little bit more complex here, and you will be able to then run various unit tests based on your application, right? Once this is done, then we push this image. So what you need to do to push this image is basically Docker tag. You tag that image first, and then once this is tagged, then you push that image, right? And as I said, once you push that image, then what you want to do is you want to scan that image, right? And for this, we have two various options. If you look at Mirantis Secure Registry in the repository, okay, in this repository, so let's say here I have a dev repository and a production repository, right? If you look at this repository, you will see that by default, the images are not scanned, right? We'll say scan out of date. I need to rescan these, right? But when I push images within these repositories, I have the ability to either scan manually or scan on push, right? So for this specific use case, I decided to put the scan on manual. So then when I'm going to push my image to that repository, right, basically, the images are not scanned automatically, right? So in this case, this is why in the pipeline, then I am calling the MSR APIs, and I am asking MSR to scan that image. So sending a request to URL, and you can see that I'm asking MSR to scan that image, right? And that image is then scanned by MSR, and based on the results, then I can define a promotion rule. But I could also, when I define this repository in MSR, I could say scan on push. And what that means is in my pipeline, I don't need to call that scan API. This will be done automatically in MSR, right? So if you do have another repository, it will work the same. So either you would call the scan API here, or if your repository has the same similar feature, you can then scan and push. And once this is done, then you have the promotion rule, as I explained. And here to add a promotion rule, I just need, for example, here to say I'm here in the dev repository. I create a new promotion rule. I select the criteria. So let's say, for example, critical vulnerabilities, I want it to be equal to 0. So I don't want to have any critical vulnerability detected in the scan results, right? And then I select the prod. I indicate the target repository, right? And then I just save. Okay. So here I just added a very simple promotion rule. So if I go to tags here and I just rescan an image, so let's say I scan this one, they will all be now pending. They will start to scan the image, and once this is done, I will get the results here, and then you can view the details in this part, right? I can also do a manual promotion here, but again, we have that rule, and it will not be promoted because you can see that that simple image has 7 critical vulnerabilities. So there is no way that it's going to get promoted to production repository, right? So you can automate all this and basically start to deploy your applications automatically. So you have your code, you commit your code, you have a webhook that is attached to your pipeline. Your pipeline get your code, build your code around that, build the image. Here in that simple pipeline, we are not signing. So this is why you can see that the image are not signed. But I could have added in this pipeline at that stage. So basically, before I tag and I push, I would have a Docker sign my image with the proper private key. And I would have pushed an image in that case that would have been signed, right? And then I define my promotion rule, and then it gets promoted to the proper production repository. And then I can also push my pipeline a little bit if I want to also do deployment through Jenkins. I can then also do a Docker run on a target or kubectl command on a target Kubernetes cluster and have that application running. And this is basically what we do at the end of this pipelines. You can see that we are calling some kubectl command in the target Kubernetes cluster, which is Mirantis Kubernetes engine here. So I'm calling this kubectl command with the selected image, and then I have a service that exposes these services directly, right? So here it is one of the way of doing it. You have other ways of doing it also, definitely. You have more integrated way and more advanced way now with Kubernetes. For example, in Mirantis, we have something which is called Amazy.io. And Amazy.io is a platform that allows you to do all these things, whether it is 1, 2, 3, and 4, or all these 4 steps in a simpler manner. And how that works is basically this is what we call the zero ops approach. So developers do not need to understand the operational side of the application. So create clusters and manage these clusters, and then deploy the applications within these clusters. How that works actually is in a very simple manner. Is you have your developers. They push their code towards their preferred system, Git repository, right? And then Amazy.io, which is based on an open source project which is called Lagoon. Lagoon then grabs through webhooks, grabs the changes in these Git repositories, and then do and automate everything. So take the code, build the images, would be able to share these images, but also run these images in target environments, right? And these target environments can be also built through the Amazy.io platform. So in this case, you don't even need to create your Kubernetes clusters. It's all being managed by Amazy.io, right? So if you do want to have more details about that, we can share with you documentation. but this is again in a way of going even further in terms of acceleration. So if you don't want to write your own pipeline to do all these different steps, you can go and look at Amazee.io and the Lagoon project on Kubernetes to go definitely way further, right? So this is on the CI piece. Now let's look at the CD piece, right? Continuous delivery. So under continuous delivery, you have definitely various things to consider. We talked a lot about the applications, right? Whether it is through Jenkins and the Jenkins pipelines, you can do the same with other CI tools like Circle CI, for example, right? You define your pipeline, then you build, you sign, share, and scan, right? Can go further, more automation, zero ops approach, where with Lagoon project and Amazee.io, you push your code and Amazee.io packages your code and pushes that to the target environment, right? And in that case, you concentrate and you build your application and bring the innovation by building your application. And then the rest of the platform is taking care of all the automation. But now let's look at also some of the components of Kubernetes, right? So you have Kubernetes, you have your applications, and you know that you need to onboard these applications on top of Kubernetes. But at that point, this also means that you also need to embed components within your Kubernetes cluster, security components, service exposition components, or like ingress components or service mesh components. You need to add logging, monitoring, and alerting tooling towards your cluster if you want to monitor your applications. You need to add continuous deployment tooling in your Kubernetes cluster if you want to enforce GitOps approach. Security components to scan images running in your cluster. And also, if you want to manage all the different events of your cluster, right? So which pod is talking to which pod or service, and manage also your RBAC posture, right? So all this needs to be added to your Kubernetes cluster. And here I said only cluster, but at the end of the day, if again we look at how many of the customers on the market are managing Kubernetes, it's not only one cluster. You have multiple clusters. You have at least the staging and production, but typically you would have multiple clusters if you are doing Kubernetes as a service and not namespace as a service. You would have these Kubernetes clusters on different environments again, different technology, whether it is AKS, EKS, or Mirantis Kubernetes engine. So you are looking at a scale problem where you need then to go and deploy all these toolings, right? And remember the challenges. The challenges are you have that ecosystem that you need to onboard, maintain, manage. It's time consuming, and you need skills, right? And you need skills that want to do that, and then also need and spend time doing that and not doing development, right? If you are in a DevOps approach. In this case, we can also then start to look at how we are going to do CD and continuous deployment on these toolings, right? On the tooling that is attached to Kubernetes, not only for applications, but for these toolings also. So this is what in Mirantis we call Lens Autopilot. This is something that relies on Lens. And what is Lens Autopilot? Lens Autopilot is a combination of tools and expertise. Our motto behind that is zero ops platform. It's the same as what I referred to for Amazee.io. Amazee.io again is a zero ops platform approach where you would be doing the apps and we would be doing the ops, right? And Lens Autopilot is the same. So Lens Autopilot is focused around the tooling for these Kubernetes clusters. Again, the focus is you would be doing the apps. So you would be doing the development and innovation in your applications. And we would be doing the rest of managing all these toolings and operations around these clusters. And clusters, again, on a scale level. So not only one single cluster, but whether they are staging, whether they are production, whether they are on-prem, whether they are in the public cloud, whether they are EKS or AKS, right? So you have that one single platform that allows you to scale out in terms of having the same level of advanced tooling for all these clusters, unified approach, and manage all these toolings, right? But it's managing all these toolings with the help of Mirantis DevOps expertise. So you have a 24/7 support on these toolings, and also to also help you onboard your application. So if you have any issues around how to use these clusters, this is where Lens Autopilot comes in. So what is Lens Autopilot and how we use GitOps to manage all this? So Lens Autopilot gives you choice. That's one very, very key and core component. It gives you choice in terms of the infrastructure, whether you want to use on-prem or public cloud infrastructure, right? So you have that choice of selecting your infrastructure. And again, in many, many cases now, you are in a multi-cloud or hybrid cloud environment. So you can select, you are not forced to use only one single technology. You have the choice of the distribution. So here we talk mainly about Linux distribution. But if we are going to talk about Windows, we have another solution for that, which I will refer later in this webinar. But if you look at the Linux distributions, then you can use your preferred one, Rocky Linux, right? If you don't want to use CentOS Stream anymore, Rocky Linux is definitely a good candidate. If you prefer to use Red Hat Enterprise, you can use SUSE, you can use Oracle Linux, you can use Ubuntu. You're not forced into CoreOS, you're not forced into AWS Linux distribution, right? So you can use whatever the Linux distribution that you want, and you have your preference, and you have your tooling, and you have your support agreement with, right? And then on top of that, then you can select your distribution, your Kubernetes distribution, whether it is pure vanilla, do-it-yourself Kubernetes, whether it is any of the public cloud distributions, whether it is Tanzu or Mirantis Kubernetes engine, right? You have that choice. So this is one of the key components behind Lens Autopilot, right? The choice of infrastructure, Linux distribution, and Kubernetes distribution. And then what Lens Autopilot does is it automates through the continuous deployment or delivery approach. It automates the delivery of all these different components based on for these different verticals. If we look at monitoring and alerting, then you would have Loki, you would have Prometheus, you would have Goldilocks, right? So we are automating the deployment of all these different tools. If you look at CI/CD for your applications, then we would be deploying Flux, we would be deploying Argo CD, we would be deploying or connecting to GitLab and GitHub Actions, right? So we are automating all these so that your applications can then leverage these tools for CI and CD, right? But for applications. Networking, we have Calico, Istio, and Ingress as the default components. But again, we can swap these. So that's why we say batteries included, but swappable. We can change all these depending on again the choice that you have at that stage, right? Depending on the choice of your distribution, Linux and Kubernetes distribution, we can adapt all these. Security, we have a full set of components, whether it is with OPA, but if you prefer Kyverno, we can manage Kyverno. We have the Aqua security set, but if you do prefer to work with Prisma Cloud from Palo Alto, we can work with Prisma Cloud, Palo Alto. We have Crane for RBAC posture management, and then Falco for event management, right? And then add-ons, these are some of the partners we work with for Tetrade, for example, and Tetrade's Bridge, Service Mesh Bridge. We also work with Trilio for the backup and recovery capabilities of your Kubernetes clusters, Sysdig for monitoring, but also security, and they leverage Falco. Security of your clusters, and then Datadog also. These are some of the add-ons, but we can also include more add-ons. So this is Lens in a nutshell. So how does that work then? That works in this. That's the setup that we have. We have this is a SaaS offering, right? The way that we are handling it right now is this is a SaaS offering in the sense that we have a single source of truth and we host our code repository as part of that SaaS offering. So DevSecOps will be manipulating these repositories, right? So we manipulate these repositories, and then you have two layers. You have a first layer which is a common layer, and a second layer which is a per cluster customization layer, right? So here you can see that I'm handling multiple clusters, right? And again, Lens Autopilot is made to handle multiple clusters at the same time. You can have an EKS cluster, you can have an AKS cluster, Mirantis Kubernetes Engine clusters, vanilla clusters, right? You have these different clusters, different environments, and you are managing all these different clusters, right? So through that single source of truth, then I have a common layer which would provide common capabilities across all these different components. Let's say, for example, I want to define a policy where I want to have security as being mandatory on all these clusters. Then in the common layer, you would have the same security posture, which is managed centrally for all these different clusters, right? And then you can define per cluster customization. So let's say, for example, this one you want to activate Istio and not on this one. So in this case, you will not be managing it in the common layer, but it will be a per cluster customization, right? So you would be then handling the code through that single source of truth with this approach of common layer and per cluster customization, so that you are able to apply the proper set of features to your given cluster. And this is what I will be showing as from now. So here in Lens, you can see that I have three clusters that I'm connected with. I'm connected to EKS. I'm connected to a Mirantis Kubernetes engine running on premise, and I'm connected to another Mirantis Kubernetes engine running also on premise, right? So for this one, I've already added that cluster to the SaaS component, so to Lens Autopilot. And if I go to pods, Lens Autopilot namespace, you will see that I have the services that are running. So you have some other services that are not running, and this is basically because of privileges on that EKS cluster, where I would need to fix the EBS privileges on that EKS cluster so that I'm able to create PVs, persistent volumes, right? So that's why some other services are not running. But the approach is the same once I fix the EKS roles, right? So this is where the Lens Autopilot DevOps would come in. You would trigger the support from our side, and then the support would help you add the proper privileges, roles on EKS, for example, to kind of fix your cluster or fix the roles, the privileges or roles for your cluster, so that then your services, not only Lens Autopilot, but your services would be able to go and claim PVs, right? So this was just to explain a little bit how that works. You create your cluster, you have the proper privileges, and as from there you can create your PVs and you can create your load balancers. But that does not come out of the box for EKS. In this case here, you can see that all the services are running, right? Because this cluster is properly configured in this case. And in terms of storage, I have all my PVs that are bound. And how that works then is I have, and I will explain this in this cluster, because this cluster, the third cluster, if I go to and I look for Lens Autopilot, you will see that I don't have that namespace. So this one is a new cluster. Lens Autopilot is not installed, and I'll explain how I'll install it, right? So let's look at how I'm going to add this cluster to the Lens Autopilot. So to do this, it's very simple. I just need to connect my cluster to my remote repository. And to do this, what I do is I call this command. Okay, so here you can see that I'm calling Flux, Bootstrap. The source of truth is on GitHub. I am handling all these clusters in a single branch, which is my development branch. And then I'm going to put that cluster in a specific environment, right? So in this case, I'm going to call it Virassamy Autopilot 2. And as from there, I just need to call that bootstrap command, right? And what will happen in this case is that Flux will create a webhook and will monitor all the changes in this branch and in this path, right? In this path repository. And this is what I meant here in terms of common layer and per cluster customization, right? And this is where we would be setting in that code base some layers as being common and some layers as being customized, right? And in that case, whatever changes I do in common layer will be applied on all these clusters, and whatever changes I do in the per cluster customization will be applied only to that for that given cluster. So here, this is running. It's reconciling, applying all the various steps. And once this is done, then I'll just activate the different components, and it will deploy all these components. But you will see also how simple this is. Okay. As this is being done, I can show you how that looks like in this current cluster. So basically here I already did the same step, right? So in this case, okay, it's done here. So now I've called the first command, which is flux bootstrap, right? So now what I need to do is go in this case in my code repository. Okay, in my branch, right? So this is my branch. Okay, so this is the update that Flux pushed towards the remote repository. So you can see that now I have that stack cluster Virassamy app2, which is created, right? So this is basically what I asked Flux CD to do, is to sync with that given AP2 environment, right? And as from there, I will now be able to manage all the different applications, Lens Autopilot applications within that cluster. So to do this, I go to Stack, Apps. Yes, I need to bootstrap first. So I'll be bootstrapping the cluster. So I need to go to Scripts. Okay, and then call the bootstrap command. Okay, and this is bootstrap command, and then I'll call the Virassamy. So it has bootstrapped. Okay, so now you can see that I have extra repositories that have been bootstrapped, right? And the bootstrap command, what it basically does is to copy some of these layers from a generic platform, a generic repository, whether it is common and per cluster, and it copied it in that per cluster customization, right? So we are taking a common base, and then we copy it, and as from there we can customize per clusters. Okay, so that's what the bootstrap command does. Once this is done, then what I need to do is I need to make modifications. Okay, so I'll do it in 2 steps. Then let me just add all modifications here. Okay, and then I push the code, right? So now I have my Git repository updated. And now what I want to do is go and start to deploy Lens Autopilot for that given cluster. So this is what the DevOps will be doing. So I go to Stack, Apps. I will go to Virassamy app2, right? And I have a customization file here because it's Flux CD. So here I open that Flux customization, and I then decide to deploy the various services that I want to deploy. So here, let's say I want to deploy everything. I want to deploy the security components. I want to deploy the service mesh components, the logging, monitoring, and alerting components, secrets, and CI/CD, right? You can see that it's coming from base, but I can also have that as a specific one, right? It's all about how you are manipulating these different repositories and configuration, and I will show you how that looks like, okay? So I changed this one, and I just need then now to commit again that change, and I will observe the changes in the repository, okay? So git status again. All right. So as from there, what will happen is that if we go to custom resource definition, you will see that you have some specific Flux CD custom resource that have been defined, right? So if you look at customization, for example, in the proper namespace, you will see that these are the different repositories, whether it is infrastructure, apps, or Lens Autopilot, right? So these are the different repositories that are synced. So it will reconcile based on the git tag, right? And here you will see that it's starting to reconcile. So if I look at git logs, for example, the latest tag is 6B and finishing to 19, right? And here you will see that the apps now is false. It's starting to reconcile, right? It's reconciling. These two are already on 6B, and this one is now reconciling. And how that works then, if you look at the Helm toolkit Flux CD and look at Helm releases, you will see that these are now being taken care of, right? So you have all these different Helm charts are being reconciled in progress, okay? And at the end of the day, once everything is reconciled, you will see that everything is ready and in true state. But right now, as we just started the process, reconciliation is in progress, right? At the same time, you can start to look at the pods, Lens Autopilot. You will see that the applications are being deployed, right, in parallel. So we just need to wait a little bit. But I already prepared another cluster for this. Again, we can look at the same information in the custom resource definition. So if I check customize here and I just look at customization here, you will see that everything is on 6B, right? Because again, both are looking at the same common platform, but that given cluster has not seen any changes in the per cluster customization, right? So it's synced because they are all looking at the same common layer, but then it's only the second. So in this case, I'm using two Mirantis Kubernetes engine. The first one has not seen any changes. The second one is now being deployed, right? So this is exactly what we are seeing. The tag is 6B. So this is basically what I showed here, right? It's 6B. But in this case, no reconciliation is required simply because no changes applied here. Everything is deployed in true state, and then the applications are up and running, right? Or up and running. Okay. Now, if I do want to have a change for this given cluster, right? And how can I do that? Let's say, for example, I want to have a Slack which is enabled. Slack alerts which are enabled on events. Okay, I want to detect mining applications, for example, right? How would I do that? The way to do that is the following. So I would go to Stack, Apps, and this one, right? You see, this is the first cluster. I would go to Virassamy App 1, right? In this one, I would look at customization here, and I would simply enable these patches, the strategic merge of these patches, right? I want to enable FileCo, and I want to enable FileCo rules, right? And we will be seeing what these are made of. So let's look at the FileCo patch. If we look at the FileCo patch, we are just creating a sidekick, Falco sidekick. We are enabling a sidekick, and on a given port, right? And that given sidekick then will be managing the webhooks and sending the events towards a given, that's the configuration of the sidekick, towards a given Slack channel, right? So that's what I want to enable. And then in terms of rules, we can have various rules that we want to apply. Here, I have defined a couple of rules, and these are basically some rules to detect a mining XM IRG, XM rig mining application, right? So these are the some of the rules that I've defined here, right? So this is what we want to apply. Okay. All right. So you can see that I changed the customization here. So again, I will just be adding this file. Okay. So I'm clean on this one. All right. So what will happen in this case? So if I go back to the Plug CD customization, you will see that it will start to reconcile, right? So at some point, after a couple of seconds, it will detect that a new commit has been pushed, and you will see that now apps is not ready anymore. It's reconciling, right? So this is why it moved from true to false. And if we look at Helm releases, you will see that it's Falco that will at some point be called, right? And it will be updated, right? So we need to wait a little bit, and then you will see that Falco will move from true to unknown and will start to reconcile, right? Just need, okay, so here you can see Falco is now unknown and reconciliation is in progress. Okay, so in this case, here is the Slack channel, and here is the lab Falco demo. So for now, there are no new messages coming in. Okay, there are no new messages coming in, but once the reconciliation is done, right? Once it is configured properly, I will start to see some notifications coming in, right? And then what I just need to do at the end in this cluster is if I start a mining application, then I will start to look at or see notifications of about a mining application, right? Right. But for that, I just need to wait a little bit to start to get notifications on this. Okay. So I am starting to get, yes, I'm starting to get notifications. Yes, I'm starting to get these notifications. Can I do a check here? Reconciliation is in progress. Some of the sidekicks must have been deployed already. And yes, you can see that I'm getting new messages coming in, right? So the Docker client is executed. So these are some of the notifications that I'm starting to get, right? So here again, it's continuous delivery of these components. So Falco I deployed it. I'm not happy about how it works. I can patch the modification and then it applies, right? And this one is only applied on this cluster, simply because again, if I come back to this slide, I changed it on a per cluster customization. But if I made the change on a common layer, so I said, okay, Falco security rules or all security rules need to be managed in that common layer. When I'm going to do that change here, it's going to push to all these components, right? So again, on a scale perspective, one single pane of glass, SaaS offering, manage all these clusters in an easier manner. Okay, so let's see how it works when I do create that mining application. Okay, so I'm creating the XM rig. So if I go to now pods and go to XM rig, the application is now running and started to run. And if I go back to my Falco, I will see that at some point I will get a notification critical notification saying that there is it has detected a mining application based on the rules that we have set, right? Again, so these are all standard messages. Just need to wait a little bit, and I will receive a notification saying that this is a critical application that has been detected on this given cluster. Okay. Yes, we talked about Lens Autopilot as being the component that we Mirantis we have built, and we use it internally also to automate all these deployment of components within these different clusters, right? Across the different clusters that we need to use. But if you do want to go beyond that point, this is where we have what we call another offering, which we call platform engineering. And platform engineering is then a very highly customized offering, where in this case, we can take care of not only Linux workers, but also Windows workers, very more complex integration. If you have very, very specific components that you want to integrate into your clusters, that is a little bit less mainstream, then we would be working for that platform engineering offering, which goes a little bit beyond Lens Autopilot. Lens Autopilot is a set of selected components where we have invested R&D, time and energy. We have selected the proper component, integrated them, tested them, and then made them automated through the SaaS offering. But platform engineering is more customized, right? So quick information about that. Okay, as a summary, what we have seen today is automation is definitely key to cope with the challenges around complexity of the ecosystem, many components to handle. And when I say handle, is all the lifecycle management of these components, onboard these, manage these, secure these, train the team, adoption, and then start to build applications on top of that. So it's already a long way through the adoption until you are able to get benefit of these tools. But automation is very, very key to do all this. Give back choice of use your proper solution, to use the proper solution based on your use cases. Select the proper open source components, select the trusted platforms, select the operating system, and Kubernetes distribution, right? Again, based on your use cases. And then trust is very, very important, and work with trusted partner that will allow you to accelerate and be in the mode of you would be spending more of your time developing and adding value into your code than spending time operating open source components within clusters or doing all the operations of your clusters, right? And this is what we as Mirantis call ZeroOps. I mentioned Easy.io. This is a key product in our portfolio that automates all that CI process, taking from your code towards deploying it in a target environment of your choice. But we also showed how we can do ZeroOps in terms of components of Kubernetes, right? With Lens Autopilot, and going beyond that with platform engineering as a service. Okay. For your information, we also have an upcoming webinar on the May 2nd, same time, about gRPC and using it in Kubernetes, and that will be done by one of my colleagues, Zachary Fanel. So yes, do not hesitate to register to this one. It's a very interesting topic. In the meantime, I can show you some of the notifications that I received, whether I received the red one or not red one, so it's still not applied, or it should be coming soon. All right. So thank you very much for your time. I hope it was a useful session for you, whether it is on the CIPs or the CDPs. If you do want to have more information about what I referred to today, do not hesitate to reach out. I'm available on LinkedIn. You have our contacts, and you will get our contacts from our team. I would like to wish you a good rest of your day. And again, thank you for your attention.